Hello everyone. Today we are going to do Mathematics 0580 Paper 2. The topic that we are going to cover is mensuration. Please subscribe and follow the channel as all the proceeds of this video will go towards the Palestinian cause. Thank you. Let's look how we can solve this particular question. The first thing that we need to realize is the rhombus is nothing but a square, and the only difference between a square and rhombus is that a square has all the angles at 90 degrees. This is not the case with rhombus. So the only differentiating point between a square and rhombus is the difference of these angles. So this means that just as the square has equal lengths, then all of these are going to be equal as well. This is the first thing that we established. Now if we go on to dissect this diagram, we can observe that this diagram is basically saying something like this. It's that these are two overlapping sectors. One sector is DAC and the other sector is BAC. Now all of these are radius. Why? Because like it says, DAC is sector of a circle with center D. So the length DA is a radius, the length DC is a radius, AB is a radius, and CB is a radius, and they're all equal to one another. Why? Because just like we discussed, a rhombus has similar length, right? Just like a square. Let's go in a deeper manner, right? If we draw a sector like this and do it like this and we completely cover it up, and here I go on to make this line then you and I, we both can appreciate the fact that okay, this colored portion is the gray area that we're looking for, right? So if we label it, I have drawn this from this particular diagram, right? This is A, this is C, and this is D. So if you guys now see, we have a complete triangle at our hands. So we have a triangle whose angle is 40 and whose lengths are 10, right? So first what we simply need to do is we need to find the area of this unshaded triangle, we need to find the area of the sector, and then we need to subtract these two in order to find this blue shaded region. How do you do this? You first find the area of triangle, but in order to do this, you first need to find the length AC. And how do you find AC? You will use the cosine law. What is the cosine law equals to? Cosine law is equals to AC squared is equals to DA squared plus DC squared minus 2 times DA DC and cos D, and then I'll take just a square root in order to find the actual length. Now we'll just plug the given values to us by the question. So just using them in red and highlighting them as I do it. The value of dA is 10, so just highlighting it, putting it 10. The value of DC again is 10, so again going to highlight it and put this value 10, repeating these values, and the angle D is 40 as given. Once we solve this, we are able to come up with the fact that this value of the length is 6.84. Now we are going to find the area of these triangles, right? Now let's go on to find the area of the triangles. So now for our ease, we are just going to make a right angle through it, right? And when we make a right angle, again these are going to be equal right angles. Just to demonstrate it on here, in the original diagram, it will be something like this. So we are drawing a perpendicular bisector which both these lengths are equal. So when you do this, this angle becomes 20, this angle becomes 20 as well. So now we are going to have to find this length, which we can call E. We need to find DE, right? And how can we find DE? Simple. So right angle triangle, we are going to use cos. So cos 20 is equal to base that I need to find, and hypotenuse 10. Once I solve these through, they come up to be 9.39. This is the value of my base. Now using both these things, I can find the area of the triangle, right? So there are two right angles, right? So I'll simply do area of triangle multiplied by this length, that is AC, right? Half of AC actually. In the end, I'll just multiply it with 2. This is half of AC, multiply with the base won't be divided as you need to take all of it, right? And because we have two triangles, we're going to do into 2, right? This cancels it out, and the area that we have in our hands is 64.22. Sorry, my bad, it's 32.11. Typo. So that is the area of the triangle, right? Now we are going to find the area of the sector, right? And how do we find the area of sector? We find the area of sector using the formula pi over 360 theta over 360 into pi r squared. So theta is 40 divided by 360 into pi into r squared, which is 10 squared. So this gives us the area of sector, that is 34.906, right? Now we will replicate this process for this sector, BAC, and because it has equal dimensions and equal angle, because equal angles are opposite, we are going to say that these values stand at both these areas that I am now going to highlight both these area stand true for both of these triangles. So I'm going to find the difference and then just multiply it by 2, because the difference is going to be same in both the sectors. The shaded area is going to be same in both the sectors because the area of triangle and the area of sector is same in both the sectors, in both the figures, right? So area of shaded region is equals to area of sector, because that's the bigger figure, minus area of the triangle in order to give us the shaded region, and this comes down to 2.79. And because we have two figures like this, we multiply it by 2 because there are two regions. We have just found of the gray area of this, but we also need to find regarding the gray area of this sector. We'll multiply it by 2, and we reach our final answer, that is 5.54. Reiterating the entire process, we are going to pull apart these two overlapping sectors, right? This is what we did in this stage, and then we demyth the diagram, that is, it is a triangle with a sector. It is a triangle inside of a sector. We find the area of a triangle by first finding this length and then this height, and then we find the area of triangle. Once you have the area of triangle, we find the area of sector using this formula over here, and we subtract the two. Now we have got an area of one shaded region, right, directly here. But because both the sectors have equal length and equal values, we are going to say that whatever this area is, this area has to be the same. So we simply multiply it by 2 and get our final answer. Moving on to a different question. Now they are saying calculate the volume of a hemisphere that has a radius 3.2. What we need to ask ourselves is that, okay, they've given us the formula of the volume, right, but they haven't given us the formula of the hemisphere. So now what exactly is a hemisphere? A hemisphere is nothing but half of a sphere, right? Just like a semicircle is half of a circle, hemisphere is half of a sphere. So we do nothing, we simply take the volume of a sphere and we divide it by 2 in order to find the volume of a hemisphere, right? For simplification, whenever divide sign change into multiplication, the value after it reciprocates, so it becomes 1 over 2. So this is your area volume for hemisphere. We simply need to plug in the radius, that is 3.2 cubed plus 6, and get an answer that will be equal to 68.23. I hope it makes sense. Let's move forward. This question asks us that the area of a triangle is given and they have given us the length of the base. They're asking us to calculate the perpendicular height of the triangle. This is the triangle, right? And they said that this triangle has 528 as its area, right? You need to find this perpendicular length, and this entire thing is 33, right? Now it's straightforward, right? So basically, oh, never mind, there's a right angle triangle. Never mind. We have this triangle, right? You can simply say that, okay, this is a triangle, we don't know the height of it, let's call this h, right? And the base gets divided by n equal halves, right? Because it's a perpendicular triangle cuts the base into equal halves. If I can draw it neatly, I hope. Right? So these two are equal in length. I hope it's a better diagram, right? This is what we need to find, h, right? And this, the area of this entire figure is 528. So I can say that height multiplied by the half of base, and we are needing, when we will need to multiply this entire thing with 2, is equal to 528, right? So 2 cancels with this 2, right? And this 2 goes, this becomes 33h over 2 is equal to 528. This multiplies, right? This becomes 1056. We then divide 33 and becomes equal to 32. So this is our height, 32 centimeters. Remember, units are important, right? Now we have a similar case just like we did before, right? They are telling us that the diagram shows a sector of a circle, center O. They're giving us this, and they've given us the area of the shaded region, right? We have to find both K and C, right? So let's start with it. Let's first find the area of sector. Area of sector would be theta over 360 multiplied by pi r squared. So this, when we simplify comes down to 3 pi. The reason I've done this is because they are looking for constants, and that's what I'm trying to give them as well, right? Then I will also try to find the area of this triangle by first bifurcating it like this and trying to find the area of the triangle, right? For this reason I need to find the base first, right? So how do I find the base? It's simple. Again, I am going to apply the area of triangle, but this time around I'll use a much simpler way. That is that I'm going to use a different approach that is much simpler. One approach is what I showed you above, through by doing the right area. The other is I apply the area of triangle directly, that is 1AB sine C. So the area of triangle in this case becomes 6 into 6 into sine C, that is 30. Right, guys? And the value that I find through this process is 9. Right? So this is the area of my triangle, right? And how do I find the area of my shaded region? So SR, shaded region, is equals to area of sector minus area of triangle, right? So these are my two answers. So these are my two values, right? My difference. So the value for K is next to pi, so K is 3. C is a complete lone integer, so it's 9. This is a prism. The prism has length 4, right? Prism forms a right angle, and the cross section is also right angle triangle. So both PAQ and ABQ are also right angle triangle along with the middle. I hope that's what the question trying to say. BC is 3, CQ is 2, and they're trying to find the angle between the line AQ and the base of the prism, right? So the first thing that we need to understand and we need to realize is that we first need to find this length, right? because that is a very that is a crucial length, and that is basically hypotenuse, right? The length BQ. So length BQ or hypotenuse will be equal to perpendicular under root of perpendicular squared over base squared. So this is equal to root 13. Now we are going to see how we can find, and we have found the BQ now. The BQ is root 13, right? Now all we need to do is we need to find the angle, right? So let's digest and digress this step by step. We have a prism, and in this prism the cross-sectional area is given to us. Now what we're trying to find is the angle, if I can show you, is the angle between this line AQ, right, and the angle with the base that this line is making over here. So this angle, precisely, this is what I am actually trying to find. So if I can imagine it, and if I can make it in 2D, this is actually what the diagram, this is what is the base of this is the base that we are going to have, right? The length of the base. And how do we find that? It is easy, right? So AC again will no doubt be a hypotenuse, right? And C squared plus 4 squared give you 5, right? So you can find that this base is 5, right? So now you have this length. Then you also know that this is 5, right? And this is the height of the triangle, correct? So now you can easily find the angle, right? So if I can be allowed and may take a liberty to show this in an easy way, this is what it's going to look like, right? This is 2, this is 5, this is 5, and this is A, this is C, and this is Q, right? So I just turned this figure into a vertical figure for me, right? So I need to find this angle, right? And that's easy, right? So all I have to do is find this angle, right? And the job will be done. So how do I do it? Pretty simple, right? I will simply go on, apply the trigonometric formula and get my job done. What trigonometric formula apply? I'll employ sine. So sine theta is equals to perpendicular, that is going to be 1, because diagonal, we are going to easily divide the base into 2, right? Into this. So it comes down to 11.53, and because we are going to do it for the both of them, we are going to get into 2, and the answer would be equal to 22.37, right? Let's move on. We should write over here, of course, 22.37. Now we are getting the part where we have to calculate the area of a circle with radius 5.1. The formula for area of a circle is pi r squared, and pi radius is 5.1, so squared will be equal to 5.1 squared times pi, right? This is equal to 81.71. They've given us a solid cuboid with base 7, so we know that base is 7, and they've also given us the volume of it. Total surface area is basically the surface area that we are going to have for all the surfaces combined, right? So we need to figure out how many surfaces are there, and that should help us get this area, right? So that's shown as that the base area is 7, right? So, and they've also shown us that the volume is 21. The volume will help us find this length, find the breadth of it, right? So how do we do it? 21 and 21 is equal to 7. The volume 7 times 1 times the x, which is this length, and this length becomes equal to 3, right? So we know this is 3. This is 1, this is 7, this is 3, the previous is 3 as well, right? So we know that we have many faces, right? We have two faces like the front face, we have two faces like the top face, and we have two faces like this. So we are going to get the area of all of these and then just simply multiply it by 2. So area of top face, that would be 7 times 3. Then we are going to get the area of the top face, that is going to be 7 times 1. And then we are going to get the area of the side face, that is going to be 3 times 1. And because there is 2 of all of them, we simply multiply it by 2. So this is 21 plus 7 plus 3. So when we solve them, these all become 31. And once you multiply with them 2, this becomes 62. We now have to find the volume of the cylinder with radius 5 and height 8. The volume of cylinder is pi r square h. The pi will remain as it is, right? R squared is this, height is this, so 25 times 8 times pi, so it becomes 40 pi, right? And once you are able to solve 40 pi, we simply get our answer, which is centimeter cube. Sorry, not I made it 5. 25 times 8 times pi. 25 times 8, 200. So 200 pi, and the value of 200 pi would be 628. Since when I square them, this becomes cm squared multiplied with cm. The bases are same, power will add, and it will become cube. So units will be cm cube. Units are important because there is a score they are asking you for it. They are saying a water tank in the shape of cuboid has length 1.5 and width 1, and when the water in the tank is 60 meters deep, right? So using this length, you need to understand that this is how long it is, this is how wide it is, right? And basically the amount of height the water is filled is still here, is still this, right? 60 centimeter. 60 centimeter converts into 0.6 meter. 100 centimeter is 1 meter, right? 60 is 0.6. So for liter, you need to find the volume. So volume of the water held in the tank is 0.6 multiplied by this width and this length, because it covers all of this width and all of this length, right? So the volume that I am getting is 0.9 meter cube, right? This is what I am getting. And now I am going to do the conversion from meter to liter, right? So 1 cubic meter is equal to 1000 liters, right? And I have 0.9, so they will be equals to x, right? Cross multiplication occurs, so the volume or the unknown figure comes about to be 900 liters. So we have 900 liters of water in our tank. This is an equilateral triangle. An equilateral triangle means it has all the lengths for this particular triangle are similar, right? So this is 10, this is 10 as well, right? And because the lengths are equal, all the angles are equal as well. So this is 60. Now, in order to find the area of the shaded region, we are simply going to subtract the area of the area of the sector with the area of triangle. They have also told us that M is the midpoint, so you and I both know that this length is radius is 5. So I'll first find the area of sector. The area of sector will be given to me by, again, theta over 360 into pi r squared, 60 into 360 multiplied by pi r squared, so pi into 25. This will become 25 over 6 pi. Let's find the area of triangle. We'll use 1 over 2 AB sine C to make our life easy. Lengths are 10 of the entire triangle. Angle is 60, right? So it becomes 50 sine 60 after cancellation is equal to 25 root 3. When I subtract the both of them to get my answer, it becomes down to 30.21. Right, so simply we found the area of the sector, right, which is here, right, and we found the area of triangle, which is here, and we subtracted both of them, right? So this is the difference, that is the shaded region. Next thing is the diagram shows a sector of a circle with radius 6. So we have radius 6, we know radius, and they want to find the perimeter, right? So what is the perimeter of the sector? A perimeter of a sector is, let me highlight these length. It is this length, this length, and this length, and this length. This length is again 6, it's the radius. How do you find this length? This length is basically arc length. In the formula finding the arc length, is first we need to convert this into radians, right? It's given to us in degrees, right? So what do we do? To convert this to degree, you simply multiply it by pi and divide it by 180 to convert the angle into radian, right? So it becomes 2 over 5 pi. That is our angle in radians. So the formula for finding arc length S is r theta. So r is 6, theta is 2 pi over 5, and that gets us our answer 12 over 5 pi. This is the arc length, right? So what's the parameter again? This is r plus s, since there are two r's involved, right? Both this and this. So 2r plus s, the value of r is 6, the value of s is 12 pi over 5. So this gives us 12 plus 12 pi over 5. So the value for p is 12, the value for q is 12 over 5. Now we need to find the height of a cuboid. They given us the volume and the square side length, right? So what is cuboid? Cuboid is basically a 3D square, a square that has, this is a square, right? And what is cuboid? A cuboid is a square but like this. So a 3D square, right? A three-dimensional square, right? Pardon my drawing, not my best asset. Right, but it's a 3D figure like this, right? So, and with square as its base. So they've given me the volume, right? The area of square, it will be 36 because each side is length 6, right? So area of square is s squared or l squared. So it would become 6 times 6 is 36. So area of rectangle, cuboid is volume of cuboid is basically area of square into the other length, right? That is unknown. So height, right? And once you and I are able to solve it by dividing it, right, it becomes 5, right? And it's, why is it not centimeter square? Because it's a particular length that we're talking about. Let's come down and find the area of this triangle, right? The area of this triangle again going to it's again going to be easy. Why? Because we need to understand the fact that whatever we do, right, even if we are able to break it into two equal lengths, this will remain the base because it's the total base, right, and this remains the height. So height is constant, so what we do is we will be finding area twice, one for this base and one for this base. In order to make our time easy, we can simply take this base, because we have to do the length for this base either way, and multiply it by the height and get our answer, right? So this comes equal to 14.7, right? I hope everything is clear and crisp until now. Let's go on to question number 14, right? So for question number 14, they want us to find find the area of the sector, right? And how do we do it? It's pretty easy. They've given us the radius, one, the most important thing, and they've also given us the angle. So we know the formula for it, right? The formula is theta over 360 into pi r squared. This is our theta, 360, right? And this is pi into r squared. This will get us our answer, right? That is 72.79. Again, they've given us two sectors. One is a bigger sector with radius 5, right? If I'm to highlight it, it would be this, right? This is the bigger sector, right? And in this bigger sector, we have a smaller sector, and I'm highlighting with yellow. So what do? You find the difference of areas between them, right? So theta over 360 into pi into r square 5 minus 45 360 into pi into r square, that is 3 squared. What we can do to make our life easy is we can take 45 over pi common, right, and this would leave us with 5 squared minus 3 squared, right? This is the essential and the most easy way to do this kind of questions, right? Because the area difference is totally belonging on the radius, you can just find the difference of squared radius and multiply it to get an answer and get done with the question, right? This would be equal to 6.28. What did we do? Instead of typing it again and getting the answer for this thing first for the bigger sector and then subtracting the smaller sector, I simply took 45 pi common from both and subtracted the variable part, that is the square of radius. We're saying a pipe is completely full of water. Water flows through the pipe at speed of 1.2 meter per second to the tank. The cross-sectional area of the pipe, which is a circle, is 6 centimeters square. Calculate the number of liters of water flowing into the tank in 1 hour. So the speed with which the water can flow into the pipe is 1.2 and the cross-sectional area is 6 centimeter squared. Let's try to break it down. So this is a circle, right, and the cross-section, this is a pipe, right, and this is basically a cross-sectional view of the pipe, right. This is 6 centimeter squared, right, the area. So this means this is the amount of water that can actually go through it, right. Let's first find the total amount of this and this is the speed of the water, right. So let's just find how much water can actually go from the pipe, right. This is the first thing that we will need to figure out, right, that how much of it can actually go through the pipe, right, for in an hour. So 1.2 can go, right, this is basic conversion, right, in meters, right. So this is how much meters of water can go. If I convert it to centimeter to get my own conversion into centimeters, it would be this, right. This is the speed of water this is the speed of water, and this is the amount of water in the entire that I'm going to in the entire hour, right. Now we need to come up with the amount of water that is able to flow, the total amount of water can go through, right, speed of water. We need to come up with the amount of water that can actually go through, given that this is the speed, right. So what do? This is the amount of water can completely fill, and this is for per centimeter, right. How many centimeters do we have? We have 6 centimeters, right. So we multiply it by 6, and this is the amount of centimeter cube of water that can flow through it, right. These. Now we need to give our answers in again. This is the amount of water that can flow per centimeter, and we have 6 centimeter of area, remember. So we need to understand how much can flow through 6 centimeter. It's easy. Now we just need to find a rate that will convert as cubic meter to liter, right. So we say that the relationship is that 1 liter is to 1000 cubic meters, right? Cubic centimeters, right? And we don't know how many liters we have, but we do know the amount of centimeter cubes that we have. Right? So this is the amount of liters of water that can flow through this circle. If the radius was smaller, smaller water would go through. If the area of the circle was smaller, the cross-sectional area was smaller, then smaller amount of water will go through. If it was larger, then obviously larger amount of water will go through it. Now they're asking us to calculate the surface area. The surface area is the visible area of a figure, right? So which two squares are visible? Well, two of these are visible, and one of this is visible, right? So 9.5 times 7, 2, plus 2 times of 7 into 5, which is for the side face number 2, right? And now the top face is the only one, which is going to be 9.5 multiplied by 5, right? You can simply solve it. And get our answer, right? Okay, this is 2 as well. Two faces are visible, right? Two faces are there, right? Surface area. So this is the surface area, right? One key thing to remember is that whenever they're asking for total surface area or surface area, we have to calculate both of the surfaces, right? All of the surfaces. I hope it makes sense. They are saying a container is made from a circle and a cone, each of radius 5 centimeter, right? So both cone and the cylinder has a radius 5, right? And the height of the cylinder is 12 and the height of the cone is 4.8. The cylinder is completely filled with water and the container is turned up filled with water, right? Then the container is filled upside down, right? They're asking us to calculate the value depth of the water, right? They've given us volume of the cone, right? And volume of cylinder is pi r square h. What we need to realize is that what has happened is that the volume that is missing is actually equal to the volume of this cone, right? So essentially the volume will remain the same, right? But instead we need to find out how much volume exactly went there, right? And the leftover, whatever it was, remains here. So we need to find the height of both of them. In order to first do this, we need to find the volume of the cone, right? So volume of the cone would be pi r square h, and they have told us that the radius is 5 for both and the height is 4.8 here, right? So they've given us both of them, right? So you and I, we can say that okay, that this is the volume of water that it can hold, right? And now we need to find the volume of the cylinder, right? So you just have to find the total volume that it could hold. So pi r square h, so pi into r squared into h, 25 into 12, right? So this is the entire water the cylinder holds. So out of this 340 went into the cone, right? So how much is left in the cylinder? Well, the leftover amount is 260 pi, and we need to find the height for this 260 pi. So 260 pi is to pi, r square remains constant, and h is the unknown. We cancel this. R was 5, 5 squared is 25. We can simply do 260 over 25, guys, right, and get our answer, which is 10.4. So this is the new height of water in cone. So this new height that I asked you to find is 10.4, and you already know the height of this is 4.8. So the total depth would be 10.4 plus 4.8, which would be 15.2. I hope it makes sense. Once again, we found the area of the cone, we found the area of the cylinder, we found that we know that only 40 pi will go to cone, the rest will remain in the cylinder. So we found the height for the rest of the cylinder, we found the height the rest of the water will cover, and added it with the height of the cone, right? And this is how it's done. There are 5 rectangles congruent to A that join to make this shape, right? So A is here, A is here, A is here, A is here, and A is here, right? So how it's done is that this is A, this is 8, this is 3 and 3. We know that this length is 3, right? So this will be 2.5 and this will be 2.5. This length is again 8 and 8. This is 3. We won't add this 3 because it is hidden. So 3, 3, 2.5, 2.5, 2.5, 2.5, 8, 8, 2.5, 2.5, 3, 3 and 8. Right? So we'll simply find how many 8s are there and simply add them together, right? So 8, we'll just multiply the figures, right? So there are 1, so there's one figure like this, right, the purple one. So I'll just do this first, right? The perimeter of this figure would be 6, 2 times 3 plus this, this, this and this, right? So this would become 10. So this is done, it's 16, right? Then there are 2 figures like this. So the perimeter of one of them, so perimeter of each of them is 16, and because they are 2, it becomes 32, right? 8 plus 8, 32, right? Then there are 2 of these, right? Perimeter for each of them is 3 plus 3 plus 8 plus 5, and there are 2 of them. So 6 plus 8 is 14 plus 5 is 19, 19 times 2 is 38, right? So 38 plus 32 plus 16, right? And this is how we get our complete parameter of the shape, that is 86, right? Why is it centimeter linear? Because we haven't squared anything at all, right? We haven't squared anything at all, we're just adding lengths. The formula for area of trapezium is pretty straightforward and simple, right? The area for trapezium is half sum of parallel length multiplied by the height, right? The perpendicular height. So these are the parallel lengths that are running in front of one another, right? So 11 plus 7 multiplied by 5, right? So this becomes 18, this is 5. So this is 45. Area of sector is found through they've given us the area and the arc length, right? And they want us to find the area. If for area we need something called the theta, right? If we use this formula, but we can also use the formula that is 1/2 rs. So we are going to employ this formula. So 1/2 into r, that is 8, into theta into s, that is 6.4, right? And we're going to get our answer. Right? I hope it makes sense. How to find the volume of the cuboid? We simply multiply the length, the breadth and the width. The width and the breadth, right? So 8, 4, 6.5, 8 times 4 is 32, right? 6 times 32 would be 192, 208. So 208. Let's come to the last one. Calculate the area of sector. So they have given the radius, right, and they given the angle, right? So how do you do it? Theta over 360 pi r squared, right? With a certain square centimeter. So I'm going to convert this into, first I'm going to convert this from millimeter into square into centimeter, right? Square it would be on its own, right? So we say that 1 millimeter, that the conversion is at 10, that 1 centimeter to 10 millimeter, right? So we basically have, we don't know the centimeter we know the millimeter that we have, right? So this would be equal to 6.5 centimeter. That's my radius, right? So 42 over 360 into pi over r squared, that is 6.5 whole squared. This square will convert it into centimeter square from the centimeter, right? So this is how we get our answer, and our answer is 15.48 centimeters square, right? Just going to explain this part again. How do we convert? So centimeter to mm conversion. 1 centimeter is equal to 10 millimeters. We don't know the centimeters that we have, but we do know the millimeters that we have. We cross multiply, so it becomes 10x 65, and the value of centimeters is 65 over 10 equal to 6.5. Then they're saying a solid cylinder has this is the radius of it and this is the height of it, right? How we do is simple, right? We take the area, we first find the in total surface area there are two things, right? For cylinder there are the two circles up and down, so two circles, and the perimeter of the entire circle that's running along the length, right? So perimeter across entire length, right? So if I make a cylinder, right, so this, it has two faces, right? Pardon my drawing, guys. Going the old school manner over here, right? right? So this is the two faces of circles, right? Marking them red, two circles, and this entire thing is a perimeter, right? So area of circle is 2 times pi into r squared, 3 squared, plus pi into r, 3, into the height that these circles are aligned for, that is 4.5, right? So it becomes 18 pi plus 13.5 pi. Once you simplify it, it becomes equal to 31.5 pi. Right? Huh. And yes, pretty much it. Just a minute, guys. Just need to cross check this where I did it manually. Just cross checking this working. Right? Just a quick fix. I forgot the 2 for the perimeter over here. It's 2 pi square, 2 pi r square, right? That is what I was cross checking in the mind for. Right? So it becomes 63 pi over 2, right? And then, guys, I'll add 18 pi to it. Right? And that gets my answer done. Right? I hope there aren't any questions from it now. Just to clean it up and sort of clean the working. So 18 pi plus 2 times 3 times 4.5, 27 pi, 45 pi, right? And 45 pi is equal to 141.37. Now they're saying that total perimeter of surface, semicircle is 19.302 3 cm, right? Total perimeter of the surface of a semicircle has two faces, right? Has consider a semicircle, guys. It has what we call this perimeter, right? But also has diameter, right? So basically this will be equal to 2 pi r over 2 plus diameter, which is 2 times r, right? This cancels with itself. We can take r common and become pi plus 2, which is 19.02, right? And if we can cross calculate it, we will get our answer, that is 3.699, right? I hope there's nothing missing here, guys. Best of luck, and this is where we're going to end the videos. Please subscribe the channel. As I said earlier, the proceeds of these are going for the Palestinian cause. Subscribe and like the channel. Best wishes, and I hope you enjoyed the video.